All right, Precalc, we're going to do one more video here on parabolas, looking at this reflective property of a parabola problem that's at the end. So one of the neat things about parabolas is that if you bounce something into them, all points on the parabola or in a parabolic reflector are going to all reflect to one particular point, and that would be the focus. So if you think about like your satellite dish at home, if you got DirecTV or something like that, what happens is all those signals come in and they hit the dish and it bounces to the focus, or it comes in from here, bounces off the parabolic reflector and goes to the focus. Comes in, bounces, goes to the focus. Comes in, bounces, goes to the focus. Wherever it comes in from, they all bounce back to the focus, which is kind of a neat thing about the parabolic reflector. So your satellite dish is going to work that way, radio telescope, whatever is going to work that way, where it all brings everything to one particular point. So that's where the electronics go, and then that sends a signal down into your house to your TV so you can enjoy wonderful programming on DirecTV or satellite dish. Same thing going the other direction, like if I have a searchlight or your car light, if you put the filament or the light source at the focus, what's going to happen is it's going to emit light, and that's going to hit the side of your, the casing for your light, which is going to be, again, a parabolic reflector shape, and it's going to point it in a particular direction. So it bounces out, it's spreading out light, but then it hits and reflects and sends it in a straight line. So you get this really powerful light source, like your headlights, like a flashlight, spotlight, searchlight, whatever it might be, is going to use this reflective property of parabolas as well. So for this particular example, I referenced, if you watch NFL games, you see guys like this stand on the sideline with these huge, glass-looking dish things. So these guys have, they're trying to catch the sound from the game, make it as realistic as possible, hear the really loud hits, all the fun stuff. So what happens is there's a microphone kind of on the inside of this goofy-looking shape that this guy who looks like Jay Cutler is holding up. So what happens is all the sound, comes in from the game, and it hits and it reflects to the focus. So again, at the focus is where we've got the microphone. Okay. So suppose a given parabolic reflector is 3 feet across, looks reasonable, and a foot deep, looks reasonable. Where should the microphone be placed? So where should the microphone be placed? It's like how, again, it should be placed at the focus. So what we're going to do is we're going to figure out where is that focus. Okay. Now to start, I am going to just do a quick sketch of my parabolic reflector, and it's easier to work with them when they're opening up. So I'm going to draw it opening up, and I'm going to put its vertex at 0, 0. Okay, so it's going to be a parabola that opens up and has a vertex at 0, 0. So the focus is really what I want to figure out, because that's where I'm going to put the microphone, is at the focus. So what I need to do is figure out a couple of things. So first of all, parabola that opens up with a vertex at the origin would be equal to x squared equals 4 times p times y. Okay. Again, p is going to be the focal length. That would be the really important thing that I have to figure out. So there's not much information given to me besides the fact that my parabolic reflector is 3 feet across. So from here to there would be 3 feet. And it's 1 foot deep. So from here to there is 1 foot. Now, what that does for me is that gives me a little bit of information, because I could identify what this point is right here on my parabola. From the vertex 0, 0, I go to the right 1.5 feet, because that's half of 3. Does that make sense? Hopefully. So I go 1.5 feet to the right, and I go up 1 foot. So if I was going to label that point right there, that point right there would be at the coordinate 1.5, comma 1. Or I could use this one over here and it'd be negative 1.5, comma 1. Okay. In any case, this is a point that's on the parabola, which means that if I substitute it into this standard form equation, it would be a solution. So if I plug in 1.5 for x and I plug in 1 for y, I would have numbers here and here, and p would be the only thing left over, and I could solve for p. So I'm going to do that. I'm going to take 1.5 and square it, and set that equal to 4 times p times 1. Now times 1, well, that's obviously going to be 4, right? So 1.5 squared is going to be 2.25. Okay, so 2.25, 4 times 1 is 4, so that's going to equal 4 times p. And again, p is the key because that's going to be the focal length. So I would then divide by 4, And 2.25 divided by 4 is going to equal 0.5625. 0.5625. Okay? And that'd be in feet. So it's that many feet to the focal length. So 0.5625 feet, that's kind of an awkward thing. So if I were to change that into inches, like take this times 12 to figure out the number of inches, that would be about 6.75 inches because it's that fraction of a foot. So 6.75 inches would maybe be a little bit better for me, okay? So I know that if that's P, that's the focal length, that would be the distance that I would need to travel from the vertex to the focus to make this parabolic reflector work out. So from here to here, I'm going to go 6 3/4 inches, okay? So that would be, when it asks like where should the microphone be placed, it should be placed 6.75 inches above the vertex. So that's another example of working with parabolas, standard form equations, and focal lengths.